Plainly, multiplication and division are opposite operations. Multiplication starts out with a couple of factors. When multiplied together, you get an answer that's larger than either of the factors. In division, you're taking the large amount and you're splitting it back into the smaller parts. That is the essence of factoring when we look at polynomials, binomials, and monomials. So I've put a listing together here of what I would consider a thinking process, how you analyze what you're looking at, whether it be a monomial, a binomial, a trinomial, or a long string of terms in a polynomial. How would you attack that to bring it down into its factors or the simplest terms? So, this is noteworthy. Please copy this into your notebooks. I'll explain them each as we come to them in greater detail, but I'd like you to have the thinking process in your notebooks available for you to actually refer to as we go along. So the starting point for me would be to look for the greatest common factor. And again, I'll explain this as we go along. I've color-coded them so you can see the steps. If there isn't a greatest common factor, or after you've taken the greatest common factor out of that polynomial, we're going to need to look and see if we've got two terms. That would be like this one, a squared minus b squared. If you have something like that, you're going to use the formula for the difference of squares. You might have a cubed minus b cubed. That's called a difference of cubes, and there's a formula for that too. And lastly, in a two-term polynomial, you might have the sum of cubes, where you'd have a cubed plus b cubed, and there is a split that's standard for that. So these three formulas are very helpful, and they're easy to use, but you have to recognize that you have a difference of squares, a difference of cubes, or the sum of cubes. So that's in a two-term polynomial. Next, our thinking process leads us to three terms. If you have three terms, here's one, ax squared plus bx is our second, and c plus c is three terms in this polynomial. In that case, there's a couple of ways of attacking this. If you have the a, if that position is 1, is equal to 1, so you're likely to see it like this, just x squared plus bx plus c. But that is telling us that the a is actually an understood 1. When it's in that position, foiling this polynomial is very efficient. If you have an a term that's greater than 1, so this might be 4x, you'd have numbers in these square positions as well. But if this one is bigger than 1, then we have to do something called splitting the factor. And I've listed the steps for splitting the factor here. For now, just write them into your notes. If you have a 4-term polynomial, we might be able to attack it by factoring by grouping. Again, I'll explain later. There's a technique called completing the square. And this formula here is kind of a universal. You can use this if they're in the form of ax squared plus bx plus c. That's the time that this one will work. So we're basically talking about this formula when we're working with a 3-term polynomial. But some of the larger polynomials, after you take out greatest common factor and so forth, you could break it down to a 3 position, a 3-term polynomial, and then in that case, this formula might work. So hopefully you've got all those in your notes, and we can be ready to roll.